Every time you type a prompt and get an answer, there's a hidden machine doing the work. Nobody shows you that machine, because once you see it, AI stops being magic. And that's exactly why you need to see it. There's a stack of technologies working in layers, and once you understand those layers, you stop guessing and start controlling. Welcome to TechWise, where we break down real AI concepts and what they actually mean in the real world. And remember, this video is part of a complete free AI course available on this channel. So if you want to build real understanding step by step, you're in the right place. Now let's answer the big question. What is the AI technology stack? It's the set of layers that turn raw data and computing power into usable AI products. Just like a skyscraper needs foundations, structure, electricity, plumbing, and design, AI needs multiple components working together. Not one model. An ecosystem. And this matters because many people think AI equals ChatGPT or equals the model. But the model is only one part of the system. Now, let's build the stack from the bottom up. The first layer is infrastructure. This is the physical and cloud foundation. Servers, GPUs, storage, networking, cloud platforms. Why does this matter? Because training and running modern AI requires enormous computational power. A spreadsheet can run on a laptop. A frontier AI model may require thousands of high-performance chips across data centers. Infrastructure is the engine room. You don't always see it. But nothing moves without it. Now, let's take this one step further. The second layer is data. This is one of the most important layers in the entire stack. AI learns from data. If the data is poor, outdated, biased, incomplete, or fragmented, the outputs suffer. Garbage in, garbage out. Data can include documents, transactions, images, audio, customer interactions, operational logs. Think of data as the fuel. Infrastructure provides power. Data provides learning material. Now, here's where things get interesting. Many companies rush to buy AI tools while ignoring data quality. That's like buying a race car and filling it with contaminated fuel. The technology may be strong. The results won't be. Now, the third layer is models. This is the part most people hear about. Machine learning models. Deep learning models. Large language models. Models are systems trained to recognize patterns and generate predictions or outputs. Examples. A fraud model predicts suspicious transactions. A recommendation model predicts what you may like next. A language model generates text. This is where intelligence-like behavior becomes visible. But remember, the model is powerful because of the layers beneath it. Now, let's move to the fourth layer. Orchestration and tools. This is where models become useful in real workflows. What does that mean? A model alone may generate text. But businesses need more than text. They need systems that can search internal documents, call APIs, read files, update CRM records, send emails, trigger workflows. This is where orchestration frameworks, integrations, and tool calling matter. The model becomes part of a larger machine. And this is where many real business use cases are created. Not from the model alone. From the combination of model plus tools plus workflow. Now, let's take this one step further. The fifth layer is applications. This is what users actually interact with. Chatbots, copilots, search assistants, content tools, analytics dashboards, automation platforms. This is the visible surface, the polished interface, the part people call AI. But behind every useful application are the lower layers doing the heavy lifting. Now, let's explore another critical layer that spans everything: governance and security. As AI becomes more powerful, organizations need controls. Who can access what data? How are outputs validated? How are risks managed? How is privacy protected? How are regulations respected? Without governance, scale becomes dangerous. Without security, value can become liability. This is why mature AI adoption is never just technical. It is operational and organizational. Now, let's bring the full picture together. A simple prompt to an AI assistant might involve cloud infrastructure processing the request, a model generating a response, a retrieval system searching documents, an integration pulling data from another tool, an application displaying the result, security controls managing permissions. All in seconds. That's the stack in action. Now, let's use an analogy. Imagine ordering food through an app. You see one button, order, but behind that button there is payment infrastructure, restaurant systems, delivery logistics, GPS routing, notifications, customer support. AI works similarly. The user sees one interaction. The real system is layered. Now, this is only half the story. Because understanding the stack helps you ask better questions. Instead of saying, "We need AI," you can ask, "Do we have the right data? Do we need our own model or an external one? How will it connect to workflows? What application will users actually adopt? What controls are required?" Those are strategic questions. And they lead to better investments. Now, let's make this practical for your career. If you work in business, consulting, operations, or strategy, understanding the stack helps you speak with technical teams. If you work in technology, it helps you connect engineering choices to business outcomes. If you're simply using AI tools, it helps you understand why some tools feel magical and others disappoint. Often, the difference is not the prompt. It's the stack behind the product. Now, here's a question for you. Which layer do you think companies underestimate the most? Infrastructure, data, models, integrations, applications, or governance? Write your answer in the comments. I'd love to see your perspective. If you found this useful, leave a like to support the course. In the next block, we move into machine learning fundamentals. We'll start with one of the most important topics of all. What is machine learning? Because once you understand the stack, it's time to understand how systems actually learn. This isn't just about using AI tools. It's about understanding the architecture shaping the future.